Okay, so definitions and methodology. Let's start with what is artificial intelligence, because this has changed over history. When AI first started back in the 1970s, it was really the attempt to reproduce mental functions in a human being by a computer. But now that's not necessarily the case. There are various approaches to AI, and this is important to remember. You'll see deep learning, deep reinforcement learning, all sorts of different kinds of things in artificial intelligence. Has to do with different types of algorithms that are applied to a particular problem. Almost all of the time, the artificial intelligence is going to replace traditional yes-no logic with some sort of a statistical clustering or some sort of fuzzy logic that doesn't exactly have just a pure yes or no all the time. It may, but it doesn't have to, include an expert representation, meaning someone has front-loaded it with a model based on an expert's knowledge of a particular situation. There are AI programs that work that way. There are others that are basically advanced statistics. One thing that they all have, though, and this is a definitional element of artificial intelligence, they all include some element of machine learning, so that the program repeats itself being applied to new sets of data, and as it continues to work on solving the same problem multiple times, it gets better and better at it. So machine learning has to be there for it to be called artificial intelligence. It's always useful to keep this in mind because AI has become such a hot topic. One of the things that my contacts in China tell me is that if you can somehow work AI into the description of your startup, you can increase your valuation by about 100%. So make sure it's really AI before you get into that. AI is really, it's the right time for AI. Not only has computing power become a lot more powerful, it's become a lot more cheap. And most AI programs require access to very large amounts of data, and data storage has become both very efficient and cheap. Without cloud computing, you probably could not have artificial intelligence most of the time, because you really have to have access to data on a scale that's not just going to reside in one machine. AI also has been a great way to approach some problems that are very difficult to do in traditional kind of mathematical analysis. A problem with thousands of variables. A problem with all sorts of kinds of strange distributions. There's a little company that does demand forecasting using AI. And instead of just a standard distribution of expected outcomes, they have a complete set of different scenarios, each of which has its own probability distribution. So you can see that the number of variables just multiplies. This allowed them, by the way, this company is called LOCAD. This allowed them to do a great job of improving the availability of spare parts for airliners, which is a really thorny problem because you never know what you're going to need to put onto the airplane at which airport you're going to be at. Anyway, AI is really good at solving some kinds of complex problems. The other thing is that AI is an essential aspect of a lot of automation problems. Smart robotics, self-driven cars, those by definition have some sort of AI in them. It would be basically impossible otherwise. I would say that most natural language interface can be considered to be AI programs. So way back to Siri. You know, if you have an assistant who gets to, a virtual assistant who gets to know you better and better and can communicate better with you and answer your questions the way you're really intending them, there's machine learning going on there, and it's an AI program. Here's a good working model of artificial intelligence. I've been using this for several years. I was happy to see that Professor Yuri Leskovitz used it this year when he was talking about trends in artificial intelligence to the big meeting for joint venture Silicon Valley. Basically, there are three kinds of levels of tasks. The most simple task is sensing or detecting something. So there's a lot of programs, for instance, threat detection or computer vision, where basically you're receiving some sort of information over and over again. You get better and better at it the more you do it. If you put more analysis into this, then you're really comprehending the situation beyond just sensing it. This would be things like natural language analysis or threat analysis or, what did I have here? New medical diagnostics. You're going over and over again to understand a situation, and the more times you do it, the better you get. Full automation is where you really get to this act stage. And so you find that with things like self-driving cars, smart power grid management, intelligent robots. There are some automated stock trading programs now that go faster than people can go. And you see all sorts of areas in which this is applied. What we're going to apply AI to in this series are what I've taken the liberty to call smart physical systems. You'll also see the word cyber physical systems, CPS. What I'm talking about is really well, I get into that. First of all, this is to introduce this survey. Danyar Galim, are you here? I don't see you. Okay. So I had two research assistants working with me this summer, Danyar Imambayev, who is in electrical engineering, and Galim Imambayev, who is in medical school and just about to start his MBA program at the business school. And we did a survey to see the extent of progress that companies in Asia have been making in applying artificial intelligence to what we're calling smart physical systems. We primarily surveyed startup companies, but we also looked at some relevant developments in big companies. So what we mean by smart physical system is, first of all, the program has to have some sort of control element in it, some sort of control over a physical system. We weren't just looking at analytics, right? You can do predictive analytics about when a machine is going to go bad in a factory, but unless there's some element of automation involved, it's not really having control over the physical system. It is something that implements some form of artificial intelligence or autonomous decision making, and they're really, the closer you get between the function of the artificial intelligence and the physical system control, the more we were interested in the company. And of course, we were looking at companies that are basically operated out of Asia or are registered in Asia. So that's what we mean by smart physical systems. We used the CB Insights list of startup companies as our primary source of companies. We only looked at companies that had received funding in Asia in the last 2 years. We sorted the companies according to a various list of categories. We eliminated a lot of the categories that CB Insights have. From there, we really handpicked each company according to the standards we showed on the previous page and tried as much as we could to avoid companies that are purely analytic, although it's sometimes very delicate to tell the difference. In agricultural technology, there's quite a few companies that are using sensors to measure the moisture in the ground and crop growth, and they will tell you how much fertilizer to put out or how much pesticide to put out on the basis of what's going on meter by meter in the field. If they just tell you to do it, is it really a controlled system or not? So, it's kind of a delicate thing, and I can't promise that we were always accurate in following that. But we also examined market research reports about cyber-physical systems, other news sources about Asia business. We looked at the portfolio companies of Asia-focused venture capital firms and other institutional investors. And we also had some similar information that we could get about what the big companies are doing from their own company press releases. So that's the kind of methodology that we used. When we were evaluating these companies, we were trying to look at their technical innovation. Was it really something different? Did it have a wow factor in it? Was it something that's just sort of, oh my goodness, here's another one? Or was it really something that was kind of, this is different? How distinct was it from other companies that are kind of sort of competing? And also we looked at their kind of recent publicity. What kind of mentions they were getting in the press. These days you can get information all over the place, right? So what did we find? First of all, these are the areas that we looked at. We divided things up into three basic huge things: smart machines, IoT systems, and smart processes. Now, of course, there's a lot of overlap. Especially by the time you get down to smart processes. Most of these we eliminated because the real developments were covered by the smart machines. Now, my research assistants did not do a survey on smart assistants, on virtual assistants, but we do have a company coming up in a couple of weeks that has kind of an interesting new approach to virtual assistants. So that's the ones that we used. We found companies that sort of generally fit into our domain of interest, right? Robotics companies, we looked at over 200 startup companies. And out of those, we found that there were really only about 27 that were using artificial intelligence for the robotic control. We looked at 88 drone companies and found 8 of them that fit our criteria. We looked at 150 autonomous driving, autonomous vehicle companies and found about 24 of them. So that's the smart machine domain. In the IoT systems domain, we looked at over 200 companies and came up with about 30 that were really kind of fitting the criteria we were looking at. And if you go on to the smart processes that weren't already covered by the smart machines, we looked at about 118 companies and we picked about 17. So you're seeing on average something that's about 1/7 to 1/10 of the companies that we looked at really were using artificial intelligence for system control, which is quite a lot. Remember, this is only Asian companies. This does not include US companies. It does not include companies in Europe. And for comparison, Angel List showed 4,731 artificial intelligence startup companies worldwide back in June. So we looked at 770 companies just in Asia. And moving into the domains of what we were looking at, industrial robotics has been a major area of strength for companies in Asia for a long time. Especially Japan has been a very strong producer of industrial robots. They still account for 52% of the world market. And this graph shows where the robots are shipped to. So notice the remarkably high growth rate in Asia, where the recipient country is one of the countries in Asia. Much faster growth in terms of installed robots than in the US or in the EU. So why? The first thing is the increase in Chinese labor costs. So China still has a lower number of robots per 10,000 factory workers than we do in the United States, and they intend to change that by 2025. So they're aiming, right now in China, it's about 49 per 10,000 workers, 49 robots per 10,000 workers, whereas in the US it's about 80. They intend to have 150 per 10,000 workers, which is on par with Japan or Korea by 2025. The main providers of robots in Japan, two of them are Japanese companies. Fanuc, which is the old gorilla for factory robots, right? When you see the giant robots that are putting together automobiles in the factory, those are Fanuc robots, almost. Well, some of them are not. Some of them are Kawasaki robots and others. And Yaskawa, which is also a big robotics company. But ABB and KUKA were the other two robotics companies that were supplying things into China, and a Chinese company bought KUKA in 2017. So the Chinese are definitely developing their domestic base of robot producers. 80% of the robots that are in China are produced by joint ventures between Chinese companies and foreign companies. So as with other domains, this is kind of what you see. Starts out with joint ventures, and then the domestic industry kicks off. The other demand that's really driving advanced technologies in robotics are a need for rapid programming and self-learning by the robot. The old way to program a robot was for numeric control. The Japanese were really good at this, but the programs are incredibly inflexible. And so if you wanted to change over the line to make something a little bit different, you had to reprogram the robot, and you had to test it out, and this took a long time. So there are, this changeover for small batch manufacturing really makes rapid programming essential. Also, there are some items like picking up different size packages and sorting them in a warehouse that you really can't do with the old kind of robotic numeric control of the robots. So that's one of the things that's driving advanced technologies. Another thing driving advanced technologies in robotics are what are now called cobots, where the robot and the person are working alongside each other, often around the same table. Cobots are much smaller. They're typically much cheaper. And the big thing is that they are flexible. They're intended to physically interact with a human. And safety, of course, is a huge issue in this. The cobot was invented about 1996 here in the US, and the big manufacturers in Japan were late. Fanuc did not start making cobots until about 2015 or 2016. So, you know, if you're really successful in something, be careful about the next paradigm of technology that's to come. But the cobots are really driving growth now, and Fanuc has a CB10 robotic arm that is growing, you know, market growth is doing extremely well. The other thing that's happening in the already industrialized countries is refitting the existing base with new capabilities, machine vision, computer vision, or other kinds of capabilities, again, that will improve efficiency, improve safety, and also enable this kind of easier changeover. So that kind of thing's happening. One of the most interesting companies in this space is a Japanese company called Mujin, which makes a robot controller, basically the box that controls the robot. And it uses deep learning to replace human teaching of the robot with automated planning. And so they have a slide that claims to reduce the time it takes to integrate a new robot into the system from a year to about 2 weeks, which is a major savings. They were founded in 2011. Kind of nice to see a joint US and Japan group founding a company. They've received over $300 million so far. The most impressive thing is every year they're growing 2.5 times, right? 258 compound annual growth rate ever since the first year they were in operation, 2012. This controller is widely applicable to different robots. It's already being deployed by a Chinese company in Shanghai in one of its biggest warehouses. JD.com's warehouse is really kind of similar to something that FedEx would be doing here, or Amazon would be doing here. And this picking boxes and putting them into the right place to ship them to the right place, that's exactly what their system is doing. Mujin received the Emerging Leader Award in a program that I'm the chair of the steering committee for, the Japan-US Innovation Awards. So we were able to get the president of Mujin, Mr. Takino, to come and speak here at Stanford in July. And I tried to get him to come to this too, but he said, we'll wait until next year. Okay, well, anyway, we're going ahead with the series. But Mujin's a very interesting company, and we'll talk to one of their competitors in this series. Drones. So that was the second kind of major type of smart machine. And here is one in which China absolutely dominates the world market. So DJI, this startup company from China, had 72% of the world market in 2017, and then basically they bought out the drone share from 3D Robotics. So they're now up to about 75% of the world market. Two other companies are noticeable in terms of world market share, and now the US is out. So China definitely dominates the civilian market worldwide for drones. DJI makes drones that are more than $1,000 and also less than $1,000, and their dominance is really in the sector above $1,000. The driver of growth in China is last mile delivery, because this is a great leapfrog opportunity. If you have a weak transportation system where it takes 3 hours to get from one side of Shanghai to the other, having a drone take your package across town starts to look a lot more economical. So the combination of sort of a difficult infrastructure plus, as we'll see, good regulation and technology advancement is really allowing the companies to do a lot more to use drones for delivery. This other Chinese company, Ehang, shows a specific way in which this is really moving into advanced areas. They got a $1 billion order for a passenger-sized drone that a person can ride in order to transport organs that will be used for transplant. And this is faster, quicker. It's a lot easier than having a team of 5 people have to have a pilot along with the person who's watching the heart beating. They're partnering with a US company called Lung Technology to deliver this. The most recent information that I can get is that it's still under development. It's still not happening yet, but the order came in 2016, and they partnered with Lung Biotech in 2017. The government regulations are kind of favoring China in regard to the development of drones. The first big problem is that in the US, you don't just have one set of regulations. You've got different regulations for every state, and you may have different regulations for different cities inside an area. The US is still in the early stages of trying to develop a comprehensive air control system. And meanwhile, the CAAC, which is the equivalent of the FAA, is not really giving people a hard time as long as you don't fly them at night and don't fly them in a high wind. But because of the kind of slowness in Japan, JD is actually testing its drones out in Thailand and Indonesia. So regulation, if you're, can slow things down. Interestingly enough, in China, Ella.me, which is Alibaba's food delivery group, got approval just this year to test drone delivery in a large industrial zone, not just over anybody's house, but it's a large industrial zone inside China. One other point about the government roles, a lot of Chinese AI looks like it's going for military application, including autonomous weapons systems and autonomous weapons delivery systems. This is not anything, there's no secrets here. This is all out of the news. You can read it. And what they seem to be doing is the drones that they're making for their own military, they're also selling to other countries because the Americans and the Israeli-made drones are too expensive. So $5 million for a system that the U.S. company would charge $100 million for. Okay. That's a business opportunity. Anyway, the government roles have kind of favored drone development in China. Now, I think an interesting company that's sort of weak on the AI sector, but it's an interesting company, is called Sharecraft. And basically, this is a drone that's being used for crop dusting. There are drones in France like this. There are drones being made in the U.S. like this. But what this one is really good at is dealing with a large area in a small amount of time. It has a cost advantage over traditional farming, over traditional approaches. And especially in China, one person buys the drone system and the neighbors all use it, right? They work out the business arrangement of that among themselves. This company is planning to expand to Japan because, quote, Japanese farmers are used to technology. Okay. Which is interesting considering most of the farming population is probably over 65 years old in Japan. But they have already got their plans to move to Japan for rice production. And yeah, the company is based in Guangzhou. It was founded in, I think, 2014, and that's the one set of money that they've got. I think they're already revenue positive. The third area of smart machines was automobiles. So here we're talking about the self-driving cars. And the U.S. is clearly in the lead in terms of how many hours of driving time self-driving cars already have on the road. I mean, just way ahead of everybody else in terms of the numbers of hours that have been driven. And also, I think that the AI capabilities of the American firms are probably in the lead. One of the lead scientists in Baidu said that we basically have to buy our hardware from the Americans. So the chips, the computer chips that are doing the AI processing are coming from the U.S. But China's really coming up fast. There was a Forbes article in May that predicted that China would deploy self-driving cars in a major way before the U.S. would. They pointed out the massive investment in artificial intelligence that's going on in China. They pointed out that it's easier to get government approval in China than here to test out autonomous driving. They pointed out that Chinese people trust autonomous driven cars a lot more than Americans do. There was some big survey numbers reported. Something like 67 or 68% of the Chinese people they surveyed trusted autonomous driven cars, and the number was like 2x the rate of trust in the United States. And there are fewer concerns about ethical issues. So everybody knows the old horse. You're in the self-driving car where, something happens and you have to hit the old person in the street or you have to hit the kid on the sidewalk. People worry about that kind of thing less in China than they do here, where the social, according to the article, the sense that what's important for the greater group is the greater need. So it's a relatively clear-cut principle, whereas we get all kind of fuddled up with things. And also, there's prediction for increasing need in China as the population in China ages, right? The one-child policy is going to cause a sharp move up in the age of the population. And one other reason that was not mentioned in this article, but was mentioned in a different source, referred to the speed with which 5G communication networks are rolling out in China. A lot of the intelligence is not just the car, it's how the car connects to the communication infrastructure, the information infrastructure around it. And China's doing a better job of rolling out 5G than we are. Again, you got a lot of local people who just don't want an antenna every couple of hundred yards on the street. The most interesting thing in autonomous driven cars that's different, that's happening in China though, is the Apollo platform, open source platform for autonomous vehicle software development. This is applicable to any kind of an automobile in principle. This is a huge change in the car industry. Everything up to now in the car industry has been closed. The APIs for software to fit into the hardware system do not transfer from a Toyota to a GM to a Ford, right? It just can't happen. But with this, they've got 116 partners in this project, including Ford and Hyundai and Bosch. And these are giving them access also to an awful lot of data about the car performance and what people are doing. So it's level 4 of the 5 automation levels, which means it's almost completely, the car is doing everything. And Udacity has already partnered with this group to provide online training for the developers writing in this language. So this could really change the automobile industry. If you have an open source platform for software development, who gets to do iTunes for the car, right? The equivalent. This is definitely going to be interesting. They're already partnering with a ride-sharing service in Chongqing and a minibus system in China. They've got plans to launch in Japan with SoftBank in 2019. So you're also seeing internationalization here too. Baidu is one of the first companies in China that's really starting to spin off entrepreneurs, kind of like Fairchild did in the United States 40, 50 years ago, where for various reasons people are leaving Baidu and starting their own company. And so we have at least 3 competing autonomous-driven companies that came out of Baidu. Look how much money these companies have raised. So Pony.ai, which has an office here in Silicon Valley, is the first one I could find. They spun off in 2016, and they've already raised $214 million. So I think they're probably a certified unicorn by this point. Roadstar.ai spun off in 2017 and has raised $130 million. And the other one, Jingqi, spun off in 2017. They didn't raise $100 million because they've had a bad lawsuit with Baidu. And that has been settled because the person who started the company has now left the company, and the company still exists. So Jingqi is still around, and they're still developing these things. Okay, this is competition. This is China. So that was the smart machines. If we look a little bit at industrial IoT, what we're really talking about is the interconnection of machines. Not so much the smart machines themselves, but how they all interconnect and can be synchronized through the cloud. Of the 22 companies that we found for our survey, 7 of them were in China, 6 in Japan, 4 in India, 4 in Israel, and 1 in South Korea. The real market drivers, if you're in a big company, the way to sell this to your company is how to predict and prevent malfunctions and do more efficient maintenance scheduling and show how much money you'll save by scheduling the maintenance when you really need it. That's the killer application for now. But really improving the whole efficiency of the system is definitely part of this, so that you may have a really fully autonomous factory. Europe is actually ahead of both the US and Asia in regard to the level of automation across the factory. And it's not surprising because another name for this industrial IoT is Industry 4.0, which came out of Germany, right? The whole idea came from there. And some of the key factories in Asia that are fully automated are actually German subsidiary factories in China. So anyway, that's industrial IoT. And I think the interesting company here is a joint venture created by two giants and a startup. So Fanuc and Hitachi got together with one of Japan's rare unicorns, and maybe the first AI unicorn, certainly the first AI unicorn in Japan, Preferred Networks. And the three of them announced at the beginning of this year this new joint venture company that has been operational since April. And the company, Intelligent Edge System, is supposed to be the intermediary between the cloud and the edge devices, whether it's a machine tool or a robot or, you know, some sort of the cart moving things around inside the warehouse, right? It's supposed to serve as that interface. I couldn't find anything since the joint venture announcement. So it's a fascinating idea, but I'm not exactly sure where it is. Maybe they just haven't put their website out yet. The president came from Hitachi, and it's interesting to see what they were bringing to the table. So Fanuc brought the robot strengths, right, and also machine tools. And Hitachi is very famous for control systems. That's the software behind the Shinkansen in Japan, and also other operational technology. And Preferred Networks brought the AI. And fascinating, because Preferred Networks is now worth about 1.2 billion, 1.3 billion, and it's a brand new company, been around 5 or 6 years. Incidentally, they're our speaker next week. So we have Preferred Networks fellow coming from Tokyo to speak in our session next Thursday. Moving on to smart cities and buildings. So worldwide, this is supposed to be a high-growth sector. What's it really involving? What's really in a smart city? What's really in a smart building? There has been, I think, a lot of technology-driven bad solutions. I saw smart house models in 1995, and they were really stupid. I don't want to live in a house like this. I want time to myself sometimes. And on a city level, too, there's been all sorts of projects. As early as 2012, Asia was really taking the lead. There were pilot projects going on in Japan and in South Korea and in 36 cities in China. And China had already announced plans to have 200 pilot smart city projects within the next few years, so by 2020 or so. The early drivers of smartness in buildings and at a city level would be energy efficiency, environmental friendliness, right? Transportation improvements. But more recently, one of the big drivers is public safety. And there was a very severe feature article in The Economist a couple of months ago about the state of surveillance in China, which is extremely advanced because they're not only identifying people, they're identifying behavior patterns and analyzing behavior patterns. And okay, so you see the public safety angle on this, but of course we worry about things like privacy and whether my version of safe behavior matches the government's version. But still, if you look at the individual cities, not the national government investments, but the individual city investments, the top 5, Singapore, Tokyo, London, New York, London again, I don't know how that happened, and then Shanghai. I think London was number 3 after Tokyo. I apologize for that. Yeah. So I think the interesting company here is a company called Guangxi Group, or a group of companies. This is a classic Asian model where a person founds a company that eventually becomes a family of company. And so this person sort of becomes the patriarch. You see this in Japan with the Keidatsu, you see this in Korea with the Chaebol. Samsung Group is the Lee family. And so Guangxi is all kind of started by this person named Guoping Liu. And Mr. Liu has been called the Chinese Elon Musk, partly because he invests in similar crazy things. They have a space exploration company. And yet, one of the things that's real business is they signed an agreement just this year with the Shanghai Security Service Company to make smart helmets that would use metamaterials and also IoT-infused camera systems. And so most likely this will be used with the smart police force, I hope. And there was no other details mentioned, but people are expecting to see the patents coming out pretty soon. So another thing that they did just this summer was to partner with Shihu New Energy Transportation Development, and now they're trying to develop an internal framework for a very, new energy vehicles. And they did this by forming a 50-50 joint venture. So you have an umbrella company now with lots of different companies kind of underneath it, all of which are still small startup companies, but you hear about these people in the news. They're up and coming. So general trends. How do you tie all this together? Artificial intelligence is a very hot topic. And I think that the investments in the Asian countries have been more aimed at these physical systems control than just purely analytics. I think the purely analytic companies maybe are still ahead in the United States. With regard to the massive investments in artificial intelligence, though, China's way ahead of everybody else. You may know that the amount, not just artificial intelligence, but the amount of venture capital invested in China last year was almost the same amount as invested in the United States. And the growth rate has been a drastic rise. So China has stated that AI is a national priority and it's going to be on parity. China will be on parity with the US by 2020 and will be the world leader by 2030. So not to be outdone, the South Koreans say we'll be in the top 4 by 2022. And so they've invested $2 billion in government money in artificial intelligence research and development. The Japanese AI market is much bigger. The market size is pretty huge already, right, for artificial intelligence, including analytics. They're predicting it to grow from $34 billion to over $750 billion within 15 years. And out of that, transportation is going to account for 30 or 40%. Self-driving cars. Now, with regard to the other aspect of growth, though, separate from investment, you have to consider talent. The U.S. is still in the lead, but there's a lot of people who are getting educated here and then going back to China. One of the people in one of those Baidu spin-off companies had worked for Tesla Motors and Google before going back to China. And, there are strong educational programs that are developing across Asia, both in the basic math and in the computer science that is necessary in artificial intelligence. The area that the U.S. has had the lead in has been English language processing, which kind of makes sense. But I think that if you can process double byte code as well as English, and you can really get the semantics right for Chinese and Japanese. You can own the world in terms of natural language processing. Still, the U.S. is pretty far in the lead in that regard. Google Translates already works for 120 languages. So the subtitle for this series is, Will Asia Take the Lead? Okay, I tried to get people in the door with that title. What I'm really interested in are more interesting questions like, what areas are the Asian businesses and Asian governments going to target? How is this going to develop differently in Asia than it is in the U.S.? How will Asia develop the policies and the institutional frameworks to support this kind of innovation? It will. And because of this sort of different development, new opportunities are going to open up here. And this is the ultimate question, is what's in it for us? And I'm hoping that both for students and for our visitors from the Valley, there'll be some really interesting and exciting content. I'm really looking forward to Mr. Maruyama next week from Preferred Networks. And we will start to look at this from next week. That's my prepared remarks from today. I'll be happy to answer some questions. Thanks for your attention. Floor is open. I'll go home. Go ahead, Walter.
I don't see any AI applied to medicine.
Yeah, I didn't really have a chance to look at the medicine. And very frankly, the U.S. has some really strong companies in this regard. Intuitive Robotics has been putting AI into their stuff. And I haven't found the killer companies in Asia, but I think that's partly because we didn't really look at medicine in our survey this summer. This was really recent work just over the last couple of months. Does anybody know any good medicine companies that we should be talking about? Please.
Hi everyone, I'm from Hong Kong, so I have some inputs from Asia. So last year I invested in a company called Ping Good Doctor. Many of you probably heard about that. Ping Good Doctor is basically an AI-powered GP consultation system. Basically, you download the app on your phone, and it can't cure cancer, but basically you can go to it and solve all your everyday cough, cold, stomach pain, all kind of problems.
So does it connect you with a human doctor, or does the AI give you the answers?
Right, so it's a combination of both. So basically they have built, a set of about 20 very high qualified global doctors that sit behind the machine, but they also have very, very powerful AI. So the idea is that you keep feeding in all your systems. The interaction is very intelligent. It's ask you more and more specific questions based on information that you're feeding in, and the AI tries and give you answers. But the doctor is sitting behind actually watching it. And if anything is amiss, or they feel that that's not quite right, or they pick on something with then they actually jump in.
Yeah, okay. So that's a really interesting company. I think mobile health and things like fintech is also driven by mobile applications is really important. Now, it wouldn't have fit into our survey because it's not a smart physical system. There's no control element in it, right? You get the advice back from the doctor, but including a recommendation to go to a pharmacy and get something, right?
Well, actually, if I can just add a couple of things on that. So the AI actually gets smarter. The idea is that there are 250,000 people using it every hour in China. This massive. Every month, there are enormous number of users using it. So the AI actually gets smarter and smarter.
Of course it does.
Right?
But my point is there's no control element where it's controlling a physical device.
Oh, but it's on the phone.
The interface.
Right.
Yeah. So that's why, and thank you. I hope you don't mind me pointing that out, but that's exactly why we tried to keep it down to the small number of companies that we looked at. But I wish we had had time to look at medicine. Go ahead.
AI semiconductor chip company included in your analysis?
I didn't really look at the chip companies, although if it was control over the equipment to make the chip companies, we would have looked at it. I have about 4 pages of AI chip companies that we're starting a big survey that's a year long this year. And the big companies are doing it, the small companies are doing it. This is a huge area. A lot of artificial intelligence is being processed on graphic processing chips because they're already faster than the old CPU chips. But if you do it specifically for a type of artificial intelligence problem, you can achieve another 100x in speed. So a lot of the self-driving car companies have got the chips that they're trying to develop. This is a really hot topic. We didn't do it in this survey, but it's a really good, interesting topic. Go ahead. So I saw another hand there.
So like in the US, there have been a lot of debates about like privacy and how data can be used, like with Facebook, especially recently. How has that played out in China? And do you think like the privacy issues in the US will kind of hold back the kind of the AI development?
I think that on the one hand, the government has always had a much more top-down view into what's going on at an individual level in China. You know, the famous Great Firewall of China. If it hadn't been for the Great Firewall of China, the internet probably could have not gotten to that country. And I've been in, you know, I've had troubles with the firewall when I'm in China and I'm trying to send files around, right? Because I don't have a domestic address. But I think that the people who are really ahead in that are the Europeans. And I will tell you one thing that happened to me just the other week that tells me how the world will develop. I went to a startup company in Mountain View that has a nice little analytic AI program, really interesting company. And I said, well, are you worried about privacy? And the CEO said to me, oh, we're GDPR compliant. The General Data Privacy Regulation is the European Union's privacy law. And by moving ahead with that standardization, they're likely to be the standard setter. If you go back 30 years, the Japanese spent a whole lot of money developing high-definition television, and quietly, the Japanese had an analog standard. Quietly, the Europeans were developing a standard for digital TV. And so guess who won? So I frankly think that this is another area where somebody's going to take the lead. I think the Europeans are taking the lead in this. I think they're probably going to solve the problems that we're all wondering what to do about. And that's good. That pulls the world forward and should help us and also economies in Asia move forward in a productive way. So, yeah, I think that watching what each other does and trying to learn from each other is the essence of international business. I think in China, as an American, I feel like it's a very intrusive situation, but that's a feeling. I think that when you come to a business proposition, people will find a way to make money, and will find a way to get the technology forward, and will find a way to solve the problem somehow. So I'm basically positive about the future, but we've got a lot to go. And I think that a lot of the people who are developing the programs haven't thought enough about the ethics side and the privacy side and other issues. If you're a technology developer, that kind of stuff makes you feel like it's slowing you down, when really it keeps you from going down rabbit trails that are not leading anywhere, is the way I would look at it. The good ethical standards should be very helpful. Thank you. Important question. Go ahead.
I think the point about AI for healthcare
Yeah.
would be very interesting because of the demographics in China. with an aging population, I think China is very interested in, you might say, things such as surgical robotics.
Yeah,
And the fact that Intuitive's patents are expiring, there
Yeah.
are actually quite a few companies, many in the stealth mode,
Yeah.
that are, being, starting up in terms of just the surgical robotics.
yeah,
But the other thing that was interesting, I think that has happened in the last few months, or the last year, let's say, in China, is the second thing you were talking about, which is the AI chips.
yeah,
And what happened in the last year, I think, is with the US ban on ZTE acquiring chips from the US.
yeah,
Beijing kind of recognized that there was a weakness
yeah,
over there in terms of the lack of the chip technology.
yeah,
And so I think a tremendous amount of interest is now being put on development of next generation chips, which could go beyond GPUs.
I agree with you.
Yeah.
I think you're absolutely right, and I think that that's what happens when you try to put a brake on. People decide we got to do it by ourselves, and they develop the abilities to do it. Okay, thank you. Go ahead.
I'd like to add some information on the healthcare
Okay.
AI, because I happily work in Beijing and Hong Kong as an investment banker,
Mm-hmm.
focus on the healthcare
Yeah.
sector. So one thing I could feel from the last year is that after the Hong Kong stock exchange, they actually changed their listing rules, is that the biotech company, even without any sales, but if you can have like some proof about your pipeline could get admitted by the FDA or CFDA in certain fields, that you can get listed. So start from the 2017, a lot of customers coming here. But as for the AI, I think so. In China, the more company with AI, healthcare is the healthcare services company, which they actually collect this users' data and use the AI to analysis. But for the drug company like biotech, I don't think the number would be very big, because for them, like, research is a very long process. So instead of using AI, they prefer use the licensing strategy.
But remember, AI is now being applied to problems that really can't be done any other way. So the whole idea of personalizing medicine according to someone's genomic makeup, that's something without the computing power you can't do. And I think that another area that the drug companies are using is analytic. It doesn't fit my smart physical systems, but they're doing analysis of the possible risk and return profiles of different applications of the compounds. And it's kind of a fancy way of doing future scenario forecasting, because it takes $100 million to put something through clinical trials for a particular application. So you want to put it in the most likely application first, right? The one that's going to be the best business first. And the drug companies are using that kind of analytical program behind what they're up to. Now, in pharma, you've got some interesting work going on in India, but the Japanese and the Chinese have not really been doing that much advanced drug development. They've largely been the drug companies have been making their money from over-the-counter products and paying the licensing fees to the big American and European drug companies. How long that lasts, I don't know. And I do think that you're going to get personalization of medicine that will bring in AI into this picture. Good, excellent. And it's interesting about the different requirements for listing on the Hong Kong exchange too. That we'll see what kind of stimulus effect that has. Other comments? You first, I saw your hand first.
So, for your information, VLab is putting on a program about improving clinical trial process. I think it's focusing on AI because it's a hugely inefficient and time-consuming.
When is that going to happen?
It's going to be here at the Faculty Club, October 15th, Monday.
October 15. We usually put the VLab programs in our email announcements, and especially the ones that will be at the Faculty Club. We've been happy to cooperate. So Venture Lab, VLab, does really interesting programs with some entrepreneurs and investors and a couple of outside experts for each program that they do. Should be very interesting. I saw your hand.
Yes. And we're interested in the open source for the Polo platform.
Yeah.
And I also knew about Tesla's open source.
Right.
So is it becoming a trend for the AI or like some smart system kind of technology development?
I see it as the evolution of the automobile industry, where the telephone did this when really Apple came out with the iPhone as an open standard, right? And their version of the smartphone really changed things. You know, there was the Palm Pilot, there was stuff, the BlackBerry before Apple, but Apple had the market clout to really get third-party developers to use their platform. And I think that between Baidu and Tesla, they've got enough clout that this may change the way software is developed for cars, period, not just AI. When you have an open platform, that becomes a really powerful thing. Very disruptive. Good. Go ahead.
So much for your sharing. I wanted to ask you something a bit more on the regulation side of things. So you mentioned a lot of many different ways in which like smart systems are being incorporated to handle physical tasks.
Yeah.
And I assume that would include critical infrastructure like transport and dams and stuff. So doesn't that leave cities increasingly exposed to more risks? And in light of this, do you think there are any functions that will never be fully automated to protect?
Okay, those are two questions. And the first question, the good news is that people are aware of this risk. And I've seen articles in the Japanese news for the last 4 or 5 months that are all about how secure are IoT devices, and really worried about that's the way you're going to hack into the whole system, right? You get in through somebody's toaster and take down the entire computer network. So I think that we're moving forward in that regard. That's a race that will never end, because as soon as you develop a way to deal with it, the bad people develop something else. But it's also something that people don't stop using just because it's a problem. So I'm pretty positive about that. I'm glad that people are more aware of it than they were until recently, because this is an area that could really be absolutely horrible. The other thing about what doesn't really become automated, so we've done these surveys about different kinds of aspects of AI for a number of years now, and one thing that comes out is that when it's a really important decision, people always want a person in the background. So like what you were mentioning, the doctor standing behind the AI, you always want a person kind of being the ultimate decision-making authority. Low-level decisions are the ones that get automated. Low-level tasks are the ones that get automated. So I think to a certain extent, executive decisions are always going to keep people at the top of the pyramid. And the other thing that does not automate well, I don't care how good the language interface is, customer service. And that's just something where I hope I'm not just showing my age, but I don't like automated telephone systems. Right? And so I think that at the end of the day, people want to interact with other people somehow. And where will they always want to do that? One is customer service. The other is a kind of area in which you really need off-the-wall creative thinking. Because basically, AI always works by analyzing what's been given. Even though there are predictive algorithms, it's a tiny bit beyond deductive reasoning, right? It's a little bit inductive, but not much. And so when you want to have something that is just absolutely a bizarre new idea, people are going to do that. And so I think as the roots of innovation, people will always be there. That's another good question. Others? If not, we've got some refreshments outside, and I'd be very happy to talk with each and every one of you in a more informal way. Thanks again. See you.